Assalamu alaikum students. My name is Faisal Bhatt, and today we are going to start or we are going to cover the remaining portion of our chapter, the acoustic dynamics. And today our target, our benchmark, our aim is that we have to complete the numericals of the exercise of that particular chapter. And that particular chapter carries the number 11 in your Punjab text curriculum. And it is conventionally or it is commonly known as sound. Okay. Now we're going to insert with the numerical 11.1. Okay, you can see the Excel sheet on your front, and the numerical number is 11.1. 11.1. Here we are, 11.1. Okay, first of all, I'm going to inject the given data from the 11.1. Okay, I'm going to read the numericals, the statement of the numerical 11.1. The statement is, a normal conversation involves sound intensities of about 3 multiplied by 10 raised to the power minus 6 watt per meter square. Now, the magnitude of the sound intensity of normal conversation is magnitude, wait a minute, magnitude of the sound intensity of the normal conversation. Normal conversation is capital I is given. It is about 3 multiplied by 10 raised to the power minus 6 watt per meter square. It is about 3 multiplied by 10 raised to the power 3 multiplied by 10 raised to the power minus 6 watt per meter square. Watt per meter square. Okay. What is the decibel level for this intensity? For the first two numericals, we'll use the formula, which is the Weber-Fechner's law. And what does the Weber-Fechner law state? It states that the sound intensity level is equivalent to L minus L naught. L is the loudness of the unknown sound. Minus L naught is the loudness of the faintest audible sound, which is pin drop. Is equivalent to 10 times logarithm of the ratio of the intensity of unknown sound to the intensity of the faintest audible sound. We'll use that particular formula for the first two numericals. Remember that if you see the word sound intensity level, if you see the word level with any of the, you can say that prefix, then it means the examiner is asking about the sound intensity level, okay, which is L minus L naught. Otherwise, the examiner is giving you the data about sound intensity. So keep this particular hint in mind while doing the calculations while solving the numericals of Weber-Fechner's law. Okay, magnitude of the sound intensity of normal conversation, because here the examiner uses the word level, which we have to find it. So it means that we have to find the sound intensity level. Okay, and you know the magnitude of the sound intensity of faintest audible sound is 10 raised to the power minus 12 watt per meter square, which we have taken as reference intensity. So don't forget it. So magnitude of the sound intensity of the faintest audible sound. It is I naught, and it is equivalent to 10 raised to the power minus 12 watt per meter square. You know, here we will see some restrictions or some limitations while using the Excel sheet, because Excel sheet does not provide you that diversity in the calculations. So using these limitations, using these restrictions, will do our work in a comprehensive and an effective manner. Okay. What we have to find? We have to find the sound intensity level. The sound intensity level, which is L minus L naught. We have to find. So in calculation, using formula, actually, the first numerical is actually the combination of two different parts, and these can be recorded. These can be asked in the final exam as two separate numericals. Can be asked. So it's a lengthy numerical. So first we'll solve the first part of the numerical, then we'll solve the second part of the numerical as well, using the formula of Weber-Fechner's law. Wait a minute. So the adhan has just completed. So we will resume from here. Using the formula of Weber-Fechner's law, sound intensity level is equivalent to L minus L naught, which is equivalent to 10 times logarithm of the ratio of the sound intensity of an unknown sound to the sound intensity of the faintest audible sound. Put values. You know that the loudness of the faintest audible sound is considered as 0 decibel. So I put the value of L naught as 0, which is equivalent to, now I'm going to apply the formula on a very direct basis. 10 times logarithm of the sound intensity of an unknown sound to the sound intensity of the faintest audible sound. Here we get the answer 64.77, and it is in decibels. You have to restrict your answer to 4 decimal places. Okay. So I'm going to restrict it to 4 decimal places. Here it is 64.77 decibels. So that is the first part of the numerical. Now what is the second part of the numerical? We have to find sound intensity of an unknown sound, and the sound intensity level for that particular sound is 100 decibels. So here the examiner has given the sound intensity level of an unknown sound, which is L minus naught, and it is 100 decibels. 100 decibels. And here we are using the formula. And what is the formula? Here we are going to copy, and here we are going to paste the relevant portion of the formula in that desired portion. Okay, now put values. This time we have to find the intensity, means we have to find that particular factor I, which is in the numerator of the parenthesis. Okay, put values. L is 100 decibels minus 0 is equivalent to 10 multiplied by logarithm of the ratio of the sound intensity, and the sound intensity we have to find in the sound intensity of the faintest audible sound is 10 raised to power minus 12 watt per meter square. Now 100 minus 0 is equivalent to 100, and 10 is multiplying here with the logarithm, and when we'll shift 10 on the other hand side of the equation, the 10 is going to divide on the other hand side with 100. So I can write it here like that, and 100 divided by 10 will get 10, and we're left with logarithm of the ratio of the sound intensity of the unknown sound to the sound intensity of the faintest audible sound, 10 is to minus 12 watt per meter square. And now 10 is to minus 12 is dividing, or is acting as the denominator of I, and when we'll shift it to the numerator, then the 10 is to minus 12 will convert into 10 is to plus 12, and we're left with is equal to 10 logarithm of the sound intensity of unknown sound multiplied by 10 raised to power plus 12. 10 raised to power plus 12. Now 10 raised to power plus 12. Here the log is multiplying. Here the log is multiplying with both of the factors. So by using the properties of logarithm, we can write it as 10 is equivalent to logarithm of the sound intensity of an unknown sound plus the logarithm of 10 raised to power 10 raised to the power plus 12. And you know very well the 10 will write 10 as the same, and the logarithm of the sound intensity plus, you know very well. By using the laws, by using the characteristics of logarithm, we know very well that the power, which is a 12, will shift as the coefficient of the logarithm. So by writing it as 12 multiplied with logarithm of 10. Now, you know the logarithm of sound intensity plus 12 into the logarithm of 10. The value of the logarithm of 10 is 1. So by substituting 1, we get 10. 12 is adding on the right hand side of the equation. So when we'll shift it to the left hand side, it will be subtracted from the factor 10. So 10 minus 12 is equivalent to 10 minus 12 is equivalent to 10 minus 12 is equivalent to logarithm of sound intensity. Now, now we have to find the value of the sound intensity. So to find the value or the magnitude of sound intensity, we'll take anti-log on both hand sides so that we can nullify the impact of logarithm. So by taking the anti-log on both hand sides, equivalent 10 minus 12 is equivalent to minus 2. So anti-log by taking the anti-log on both hand sides, we'll get for anti-log, I'll use the formula that is 10 raised to power minus 2, and the answer is 0.01, and the anti-log will cut or will nullify the impact of logarithm on the right hand side, and we're left with the sound intensity. And the value of the sound intensity, the magnitude of the sound intensity is 0.01 watt per meter square. If you have any query on that particular numerical, you will contact me for further clarifications. Jazakallah.